Welcome to the PhysicsPlace, the place to learn about physics. And in this video I'm going to show you how you can write down decay equations. But before we go there, we need to remember the three different kinds of radiation. So we have alpha particles, beta particles and gamma rays. The alpha particle is a helium-4 nucleus. The beta particle is an electron and the gamma ray is a photon. The helium-4 nucleus has 2 protons and 2 neutrons, the electron is just one electron and the photon is just a photon. Or in other words, a package of energy which has a certain wavelength. But no mass. The correct notation for the alpha particle is 4,2 helium. This is the notation we will use in the decay equations. Sometimes this notation is used still 4,2, but then there's the alpha sign. For the beta particle, the correct notation is 0, -1 and a small letter e. Sometimes this notation is used where we can see the beta symbol. So what you can see here is that the electron has 0 mass and it has a charge of -1. And finally, the gamma ray is shown like this: 0 mass, 0 charge, and it has a symbol gamma. To show you how a decay equation looks like, I'm going to give you this example. When 233-92 uranium decays, it emits an alpha particle, a beta particle and a gamma ray. The decay equation will look like this. So on the left side we have 233-92 uranium. This one will decay, so we write down an arrow. And the following particles will be emitted. An alpha particle, so a 4,2 helium, plus a beta particle, so a 0, -1 e, and a gamma particle, which is 0, 0. And we write it down like this. As you can now see, we had 233 mass, 4 mass has left, 0 here and 0 here, so we still have some mass left. The same for the proton number. So there's still something left, and you need to determine what it is. And the rule is that if we add all numbers here, it should equal to 233. And the same down here. If we add all these numbers, it should add to 92. So first the top. We have 233, 4 already left, and the rest is still in this particle. So this particle has a mass of 229. We will do the same with the proton number. We have 92 here, -2, that's 90, +1, that's 91. If you know this number, you can look up what element this is. This one is actually protactinium. And this is how a decay equation looks like. So on the left we have the particle which is radioactive, which is about to decay, and to the right we have all the particles leaving this one plus the element which is left over. And remember, all the numbers at the mass should be the same as at the beginning, and all the numbers here for the proton number should be the same as here at the beginning. There now will be 3 examples to check if you know how this works. So the first example, when uranium-238 decays, it emits an alpha particle. Give the decay equation. Try this one for yourself and pause the video now. First we write down the correct notation for uranium-238. It looks like this. We know that it's 92 because here in this table we can see that the proton number for uranium is 92. Now we write down an arrow. And we write down all the particles which are left because of radioactive decay. In this case, it's an alpha particle, so 4,2 helium. Now we can determine what particle is left. We had a mass of 238, 4 already left, so 234 is left. The proton number was 92, -2, it's 90. Now we can see in the table which element it is. With a proton number of 90, we can see that this is thorium, so Th. And this is the correct decay equation for this question. We will now go to the next question. When Neptunium-239 decays, it emits a beta particle and a gamma ray. Give the decay equation. So try this for yourself and pause the video now. First, we write down the symbol for Neptunium-239. And it looks like this. Neptunium, here we can see it's 93, so it has 93 protons. Now we draw an arrow and we can see which particles were left. First, the beta particle, a 0, -1 e, plus a gamma ray, 0, 0, gamma. Now we can determine what particle is left. So we had 239, Nothing left here, nothing left here, so it's still 239. Here we have 93 plus 1 because this one was added, so it's 94. You can check this because if you add 94 to minus 1, it will be 93. Now we check the table. With a proton number of 94, we can see that it's plutonium. So we write down Pu. And this is the correct decay equation. Please note that this gamma ray doesn't add anything, but you still need to write it down. We will now go to the third example question. When plutonium-241 decays, it emits an alpha and a beta particle. Give the decay equation. Try this for yourself and pause the video now. So first we write down the correct symbol for plutonium-241, which is plutonium-241 94, as you can see here in the table. The proton number is 94. Now we draw an arrow and we draw the particles which were emitted. So an alpha particle 4 to helium and a beta particle 0 minus 1 E. And finally we can determine what element is left. So here we have 241 minus 4, which is 237. Here we have 94 minus 2, which is 92, plus 1, which is 93. We can check this proton number, 93, and it's Neptunium, so we write down Np. And now you have the correct decay equation for this question. That's it. You should now know how to make decay equations. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.